Ohm's law. Everybody always sees this. You know, this is big. You know, here's your watts, here's your volts, here's your ohms, here's your amps. Right? And here's another orientation of that. And everybody knows that. Nobody ever remembers E, I, or R. Well, what does everyone remember? Remember your volts, remember your amps, remember your ohms. There's 3 different forms of the exact same formula. Right? So if I have 2 items, I can figure out the third. These are all things that are on your meter. So if I go check the voltage, put an amp clamp, check the amps, I can figure out how much resistance is in that circuit. What's going on with that circuit, what's moving through that circuit. Just by using a simple little formula to do it. Right? Now, the way in which we wire our circuits. Series is our first, most common. Right? We have our 12 volts here. We have 2 amps going through. We have a 1 ohm, a 2 ohm, and a 3 ohm resistance. And each resistance is going to require a different amount of voltage to push through it. But your total amperage is connected to all of them as they're going through. Now, how do we use series most commonly on our batteries? Our series power. I have 2 12-volt batteries. I combine them, I get my 24 volts now. But you'll notice my current, even though I have 2 1,000 amp batteries, I still only have 1,000 amps to use on them. So when you're looking at 2 batteries to create your 24, or 36, or however many they run in series with each other, your voltages will add, but your currents won't. Now in a parallel circuit, we have our voltage, we have our resistance going through, we have a consistent 12 volts going through each one, we have a different amperage going through each resistance, right? Voltage, same as the source, add current of each leg for our total current. Right? Now how do we use this? Well, we use it in the batteries again. Here I have 2 12-volt batteries again, each 1,000 amps. But my total system voltage is still 12. And now I get all the amperage from the 2 of those batteries. So when you're looking at your trucks and you got your 2 to 6 batteries wired up, and you're wondering, how do I get 12 volts out of 6 batteries? This is how they run them. They add up all these batteries in parallel, and you get your total system amperage out of it, coming through them. And in some cases, they'll run series parallel power. So say I have something that requires 24 volts, but I want some more amperage out of it. Well, put them together. So I have 2 batteries in series here. I have 2 sets of batteries in parallel. So now I get 200 amps, or 2,000 amps, but I've got 24 volts out of the system. This is how they'll most commonly run on transit buses and different vehicles. Now, our batteries, as I said this morning, they're used to store electrical energy and provide high current for starting. That's their job. They also supply power when demand exceeds alternator output. This is a fun one to figure out if your system's overloaded. While you're wondering why you had a vehicle come in with dead batteries, you check the charging system, everything checked out fine, but you're still having issues. Your battery supplied that voltage to get the system going. It also stabilizes the voltage. So the alternator will output voltage, and if it doesn't have batteries, it runs batteryless. Because the batteries created a resistance in the circuit that you no longer have, your voltage will start rising up. It's one of those main things with those battery disconnects. You don't want to shut the battery disconnect off while the engine's running, while the alternator's outputting. When you do that, the batteries, their load is lost. And when your resistance drops, because of Ohm's law, our voltage is going to rise. It's going to cause issues. And they also act as a reserve capacity. Now you can have multiple different types of battery constructions. You can have your maintenance flooded lead acids, your low maintenance lead acids, and your AGMs, most common types that you'll deal with, like I said earlier. Our batteries constructions right? 2.1 volt each cell. Got our 6 cells. You can see our positive to negative going across. This is one line as we're going. We're mold there. We have our sediment chamber at the bottom. Keeps the plates from shorting out on each other. Now here I have a fully charged battery. I have my positive electrode, my negative electrode, my electrolyte, 64% water, 36% sulfuric acid in this case. I have my lead dioxide, my sulfuric acid, and my lead. Now when I take that battery and I discharge it, my molecules move over, and I'm left with lead sulfate, water, and lead sulfate. To go back to a fully charged battery, I have to undo that chemical reaction. I have to get that sulfate off the lead and move it back to where it needs to be. For our battery chemistry, standard lead antimony, 2.35 volts per cell, 14.1. Maintenance free, 14.7. Most AGM, 14.7 to 15 volts. These are our charging voltages that we're dealing with. On certain alternators, you will see set points on the regulators. The set points on the back of the regulators are adjustable. The set point is based on battery type, because different battery chemistries like a little bit of a different charge for each one as they're going through. And you can see we have a high of 14.5 here, and that's not regulated to any particular battery.
So this new sticker you see on NEHUF regulators now that are being produced, when you see this type of a setup, there's also a second port on the regulator. The second port on the regulator will allow you to remote sense and temperature compensate your charge. So if anybody's buying a Spartan chassis right now, it's got a NEHUF on it, it has that feature on it, but Spartan does not put the harness on. What the harness will allow you to do is, let's say you have AGM batteries, set point 3 on the regulator. There's a pre-programmed curve inside that regulator that will sense battery temperature and voltage at the battery and adjust accordingly by the curve that's inside the battery. This is a new feature for us in the commercial market. We've been doing it for the military for years, and actually also OEMs are doing it now as well. So this feature is now available for this market. A lot of regulators have that feature. If you want to put that feature on and it's not on the vehicle, you can call Dan and get the appropriate regulator.
Yeah,
and then all it is just a regulator change and a harness to make it work. But
yeah, so you don't have to change the alternator. The same alternator work with the different regulator. In that case, that you get the different voltage set points that'll adjust for temperature. Because in certain cases, the batteries with temperature, when they get hotter, they want to see less voltage. When they're real cold, they like to see a little bit more. So now we take advantage of that using the temperature sense harness. It allows us to charge them as efficiently as we can going through with them. Here's a little battery comparison. We have our open circuit voltages for our different types. We have our charging voltages, as you usually see. Here's our current draw. This is a fun one. So the current draw when they're depleted. So you've got a really dead battery, you're at your 10.56 and whatnot. They can draw our flooded lead acids 25 to 40 typically. Same thing for our maintenance free. When you get to our AGMs, you can have 100 plus. I've seen a transit bus vehicle that when the batteries were depleted down to about 21, 22 volts on a 24 volt system, they pulled over 350 amps when the alternator was able to output enough. So you can have a pretty high pull on those AGM batteries when they're really depleted. You might have to deal with. Then we have our cold cranking amps, our weight. You can see as they go up, we get a little bit heavier on those AGMs. And then our storage life, we put it at 6 to 12 weeks for our flooded lead acids. Our maintenance free, again, 6 to 12 weeks. And our AGMs, we get 8 to 24 months. And this is our storage without maintaining them or looking at them. If you maintain them, keep them on triple chargers, handle them properly, they'll last you much longer. These are the standard things that you see. Charging and jumping. As always, you should use a charger instead of jumping a vehicle wherever possible. It's always better for the batteries, it's better for the alternator, don't jump them. We know that in certain cases you're gonna have to do that, but if you can limit the number of times you do that to them, it's gonna be better. When you jump a dead vehicle, you're putting that high amperage output from the batteries into the system. And the system can actually become overloaded because it's not only trying to charge all of its other vehicle loads, it's also trying to charge up those batteries. And those batteries can draw a lot more than what you'd expect when they're coming out. Again, your vehicle charging system may not be properly diagnosed unless the battery is at least 90% charged. So if you come up to a vehicle that has dead batteries, you have to charge them up before you can start ruling out whether or not it's the alternator or whether or not it's a battery issue or a cabling issue or some other issue going on with the vehicle. Your charging rates and settings are going to vary by your battery type again. So what batteries you have, you got to make sure how they're supposed to be treated, how they're supposed to be taken care of. What do they want? What do they need? And what are you dealing with? So when you just come up to a vehicle, what voltages are you expecting to see on those batteries? Because again, it's going to be a little bit different. Same thing with the charging voltages. They're going to be a little bit different based on your battery types and what you're seeing. Now here's a manual charging profile. We have 12 down here for our voltage, high of 17. Then we have our current, right? So our voltage is at 14.5, steady going across. And as our voltage rises a little bit, our current drops down. Because as the batteries get to their full state of charge, they don't take as much current going in. On a 3-stage automatic charging profile, things get changed a little bit. Now we have a charging system that will charge between 13, it'll jump up to 14.5 during the high point in which the system needs the most current. As the current drops, the voltage settles out. And then once it sees that the current has dropped enough, now our charging drops the voltage down. Because you only need a certain amount of voltage to trickle those batteries down as you're going through with them. Here's our battery state of charge. We have our specific gravities here. We have our state of charge. You can see 1.225 is our 75% charged. We have our battery voltages here. We also have them for our AGMs. So you can see our battery voltages will be different sitting fully charged between our AGMs and our standard lead acids. And again, our 11.9 or lower, it's discharged. So if you come up to a vehicle, it's got 10.5 in the batteries, they're discharged. You got 7 in the batteries, you've probably caused a lot of issues with those.
So we did a build in FDNY where they built 70 trucks, knee-off alternators, 400 amp units. They were cooking alternators about 6 months in. We go there to find out that the alternators are severely overloaded. Whoever did the build, I'm not going to throw them under the proverbial fire truck, but the unit, when they did the load calculations, did not include battery loads. It was way off. I think the alternator at idle was 60 amps under what was needed. And so FDNY, what they put on their truck was a high idle switch. Kuzma makes it. And the voltage that they chose for this switch to kick on was at 11.9 volts. So if you look at that chart there, batteries are discharged. So they let the alternator go all the way down to 11.9 volts, try to keep up with this load until they went to high idle. At that point, you cycle your battery, right? So how many times can you leave your headlights on in the car, let's say, before batteries jump? I was sitting at a table with all the brass from FDNY. We were talking about this, and I tell them, you've got to be going through batteries. And the big boss there tells me, no, he's not. The other guy at the end of the table, one of his underlings, is nodding his head, yes, they are. He goes, what? We are? He goes, oh, pallets. We go through pallets of batteries. you know, we're just like, well, this is what you're gonna have to do. That switch that was at 11.9, they sent them back to cruise valve, reprogrammed it to 12.9. The pulley on the alternator, they went to a smaller pulley to spin it faster. That was their fix. After that, things quieted down. But them not knowing battery voltage at 11.9 was a discharge, was killing them. Not just, you know, alternators, but batteries.
I'll make a comment there as a battery guy. We see that in all industries across the board where people don't understand what voltage relates to actual state of charge within the battery in every application for cyclic application. And your point is well taken where you want to assist the battery bank before the battery bank gets to 100%.
Oh yeah, you don't want to get to that point.
You don't want to get there. You want to kick in right.
And the other thing about this, you know, you have shore power. If you guys noticed on this first slide, he was talking about the things he's going to discuss today. Shore power is one of them. All you guys take advantage. You'll take your cruise ball chargers, you know, as they are. You know, you got a little help there. The standard cruise ball charger that you guys buy today, if no one knows better, they will order a 20 amp charger for your truck. Right? Okay, what is your parasitic load? Does anybody know on a truck? I mean, what you got? Computer, charging flashlights, radios, apartment doors are open. Does anybody know what the parasitic load is? It's probably closer to 20. So if you have that 20 amp Kuzma charger on your truck and your parasitic load is 20, are you charging your batteries?
What I found out later too is you don't trust your charger because it says it's a 20 amp charger, doesn't mean.
Oh, that's true. So in the perfect world.
Yeah, so you're using less than that.
So in essence, we'll get to this later on, but if you're not charging your batteries and you're at 11.9, now you're gonna start your truck and go off to the call. You're expecting your alternator to charge your batteries at the call with all your scene lights on. You know, by the way, if you're starting your truck at 11.9 volts all the time, what's that good to your starter? You know, so think about how everything's all interdependent. So keep that 11.9 voltage number in mind. Okay, sorry, James.
So here's so we're talking about life cycle, depth of discharge. So here's a graph and data. Here's our depth of discharge and the expedient average cycles. So the more you discharge it, the less cycles you're going to get out of it. Just standard fact of how batteries are designed. So the more deeper you get, the less that you are going to be able to get. So if I'm discharging this 100%, I'm only getting 500, whereas if I only did it down to 10, I'd get 7,000 cycles out of that same battery. So it's the same, whether or not, the old lady's just driving her golf cart out to the street, putting it back in, charging it, or the guy takes it out, runs it out all day, gets to the point where he's got to call, have it towed back to the garage, and then put it back on the charger. It's going to affect how long those batteries last. Then for battery testing, we have our load tester. About half the battery is cold cranking amps. Here's our minimum load test voltages at different temperatures, ambient, that you're going to see. So temperature, when you're taking those tests and readings, is going to affect it. If you're doing it on a day when it's 30 degrees, your voltage is going to be a little bit different than if it's on a 70-degree day. And again, here we have our carbon pile tester. This is a copy of a VAT40 kind of tester, putting it in, loading it up. The automatic electrical testers, you just put your readings in, they'll do the math, give you out what they say it's going to be doing as you're going through with it. Now, for the alternator. It provides our power for running the vehicle loads and maintains the battery state of charge. That's its whole goal, is to keep the system voltage at the level that it needs to be while the vehicle's running. The alternator, internally, you have your field coil, which creates our magnetic field. When we apply our voltage, we have our magnet coming in here. This is a Niehoff field coil. All the Niehoff units are brushless. So they don't have any slip rings or bushings to go out or go bad. And pretty much any vehicle that is brushless, what they've done is they've removed the brushes and slip rings. They made the field coil steady, so it just sits there around the shaft and induces your voltage out, so it doesn't spin or move at all. The shaft is just a piece of steel spinning as you're going around. And it's just a coil of wire inside the unit. We have our shaft and our rotor. Our shaft and our rotor, when combined with our coil of wire, creates our electromagnet as you're going in. When you spin the electromagnet, it induces voltage into the coils and the stators, and you get your moving magnetic field going through. This is a Niehoff rotor, so the field coil would sit right there in the middle and induce out the two rotors in the system. Here's our rotors. So the rotor, it's laminations stacked together and bolted, and then this is bolted onto our shaft, and it's rotated by it as it goes around. Some designs, they'll be solid state, some of them will be welded for some other manufacturers. We just do this because it works for us and it's how we build them. As you can see, you have a couple of different styles here. So we have our rotor and our shaft and our field coil. You have your rotor, your shaft, and your internal field coil with your slip rings and brushes. So if you have a unit that you know has brushes and slip rings, you're gonna have to make sure to test those before failing the unit. You might just have a bad set of brushes. You might just have some debris in the back of the unit that's stopping the connection from going to there. When you have a brushless unit, debris doesn't matter as much, other than the fact that it would clog up the system and cause it to get too hot, heat up. So when you don't have those, all you have to do is worry about the resistance of that field coil when you're testing out the system. Now once we have our field coil and our rotors, we have our stators. Our stators has 3 windings, each 120 degrees apart. So this is one winding. So you see we have 1, 2, and 3 as you're going through, because it's 3 phases as it's going around. You get 3 pulses coming out. On Niehoff, we have 2 stators, so we're actually a 6-phase machine as you're going through.
You see a lot less ripple because of that? Alternating ripple or anything? What's the purpose?
Ripple's subjective.
What's the purpose?
What's the purpose of?
The last one you showed the 2 stators.
Oh, the 2 stators, that's for output.
Yeah, and one's actually dedicated north and a dedicated south.
South.
That's magnet too. So.
Yeah, so what you normally have is when you have one stator in a tube, your north and south poles are always swapping back and forth as you're going through. On ours, so like on the rotors here, this one will be north, this one will be south as you're going around. On ours, this is north, this is south, give or take. So that's how ours.
You have no
does it.
losses.
Yeah,
Those
right.
switch
That's why I asked about the ripple.
Yeah.
3 phase.
The thing with the ripple is that it's subjective to each unit. So on some testers, ours shows as having a higher ripple. On some, it shows a little bit lower. It just depends. Generally, for when you're testing for ripple, and we'll get to it in a minute, it's a consistency of the pattern is more important than the amplitude of what you're actually reading as you're going through with it. So our rotor pulses the magnetic field through the stator. Stator turns magnetic pulses into AC current. We generally on stators you have 2 windings styles. You have a wind where each phase goes to a neutral point, and then you have a delta design where all 3 phases go out. Ours are generally delta wound. You'll see that in our wiring schematics. You'll see the stators are shown by showing this delta symbol in them as you're going through. One thing to remember when you're testing a delta wound is it's a little bit harder to catch those down legs because you're going to read the other 2 legs going through the neutral and ground. Whereas when you have a wind and you have a down phase, you'll know because you can check between the neutral and the phase lead, and you'll be able to tell that that leg is down. So when our alternator spins, we get induced positive and negative voltage spikes going up and down. The output only happens as it spins. So if the alternator isn't spinning, it's not going to output anything. It only happens as it spins around and goes out. And our peaks, when the magnet is close, we get our positive. When the magnet moves away, we get our negative. When it's close, we get our positive. When it goes away, we get a negative. Because as the field is moving constantly, you're getting changes up and down, which creates our AC output. So coming out of our stator, we have our positive spike, and we have our negative spike. And it goes back and forth, doing that over and over again as you spin it. Now, speaking of your AC, there's our AC pattern, and that's our ripple. So when you 1/2, right, so here I have all three phases wired up here and showing. And as each phase comes around, as we go up and down, those peaks as we come down and come up, create a ripple. Now, does that look like a bad ripple pattern? No, because it's consistent. What you're looking for whenever you're looking at ripple, if you have somebody that has an oscilloscope and wants to show it off, they bought the $4,000 Matco or Snap-on Modus, and let me go hook this up and show you the ripple. Oh, look at this. No good pattern recognition. Whenever you're dealing with an oscilloscope, on any pattern, but especially on ripple, it's known pattern recognition that you're going to see. And for ripple, it's repeated pattern. So you'll be able to count as you're going through and figure out where you have a dip out in the circuit. But a little dip could just be it's coming back down. Might not actually be something bad in the unit. Generally, if you're getting that tight into ripple on the unit, you're either misdiagnosing or you need to find something else to do that day because you're just having too much fun with your new tool. So, what do we do with that?
Something.
What series of alternators is that?
That regulator is now available for everything. That's being,
So it would be our 500, our 600, our 700, and 800 series.
Just software downloaded off your guys' site.
yeah, we can send you the software, but to get that to work, I mean, so if you have an old legacy Niehoff alternator, ones with the flat 5-pin connectors, we'd have to give you like, do you have one?
So if you
Yeah,
have
that
an
type
older
Metro
style,
Pack
has this
connector. We can give you an adapter plug to put one of the newer regulators on if that's what you want, to make it work on the older style trucks. So, and you can still keep the old, pardon me?
You have the 700s.
The 700 series, yeah. So we can do that with, that's a flat 5-pin, except for the newer 714, I think it's got the
The
round
round
6-pin.
Yeah, we have adapters that will let you switch from the older style
Yeah, so you can
So
keep the old
the alternator
on,
plug-
just switch the regulator.
and just plug it in.
And a harness, you get the harness. You didn't bring a harness, did you?
The generator there? No, we got one.
So the harness fits in that 10-pin. It'll have 2 wires that go to the batteries. One goes to the positive, one goes to the negative for the sense and the temperature. And then there's a
3-pin
3-pin
connector for
triangular
the
plug
generator.
for the Jetty 239.
Yeah.
So it's all on that harness.
And you can also have multiple alternator systems. So in some cases where they have 2 alternators, we actually have it where our regulators will talk to each other to figure out who's doing more of what loads. We put them in leader-follower conditions.
Well, actually prevent the follower.
Well, yeah, prevent leader-follower, but let them run more in parallel. So not so much one guy taking the brunt of it and the other guy just hanging out. They'll actually share those loads throughout the system and they're not fighting each other.
I think there are a lot of Series 60s that are out there that had dual leases on them. I don't know if you guys have any around here, but for a while they were making dual alternator setups for apparatus, and a lot of them had dual lease to bills. And they had master fouler, one alternator would cook before the other could take assume most of the load. And what this does is it prevents that. So it controls the fuel coils on both units, so they both work equally. So one alternator won't get overloaded.
On our regulators, we have a set point, so when you turn the regulator over, you see a little switch at the bottom with 4 positions. And the 4 positions will be called out for what voltages that they're gonna output, or they'll show for battery types.
That's one of the older ones.
Yeah. And so we have, our different positions, there are different battery types. See down here, we had it called out for battery isolators. In certain applications, we had that. On some group 31 batteries, if you're boiling or excessive voltages in the system, you can switch back and forth between different positions. So if you have our temp sense harness, it'll automatically adjust for the temperature of the batteries. But if not, one thing to always keep an eye on is that when you are changing the regulators, what was the set point that you took off? Because from the factory, they'll come with a certain set point put on them, and your replacement ones will usually be at a default setting. So you might have to change. So the old one you had was at set point 2, the new one you got came with set point 1. So you might have to change it around.
Or if you're changing your batteries. If you go to AGM, then you might want to go from set point 2 to set point 3.
So we're already set up to compensate for if you want to switch battery types or styles around. You just have to change the set point on. Here's a quick little reference for our inputs and outputs. So any terminal called IGN or E on our regulators, it's going to be our input. It's our battery voltage. It is a required connection to it. It's one of the only, it's actually, other than the alternator connector, it's the only required connection going into the regulators.
And a lot of the newer ones don't even require it anymore.
Yeah. We have AC, P, and R. That's an output, usually 7 volts AC. This was usually used for our tachometers, our relays, or charge indicators. Now a neat one that you can do with that terminal, because what it's doing is it's outputting a phase tab. So if your multimeter has a frequency setting, you can go to your frequency setting, connect up to that terminal, and then to ground. You can get the speed of the alternator as it's going around, which can be helpful in diagnosing belt slip. Or if the tach on the vehicle went out, you're trying to wonder, trying to set it up for speed or different things. You can go in there and check it and see what it's actually at. Or if you're trying to figure out alternator output, because all the curves that you will see for the alternator will have the alternator RPM on them, which is a 3-to-1 ratio of your engine RPM. So to save yourself having to do the math, you just hook up to that AC terminal and see what it's doing. Now when you do see that, you'll see a point. It'll be, say, 120.0. Ignore the point. Read it as a full number. That's 1200 RPM as you're going through. Our last output is our D+. It's usually battery voltage, not more than 5 amps current draw. Usually for your relay, charge, or indicator lamps on your vehicles as you're going through.
Yeah, I'll say this, that most of the time on fire, the only terminal that you guys will use is probably the E of ignition on a lot of our older units. AC, PR, D are typically ones that we use in the bus market, so you won't use them here typically.
So, some battery absorption dynamics. Your conventional charging, your average performance for all situations, undercharging at low temps, overcharging at high temps. Your set point is set at a standard point. Optimize or smart charging. We get back to that 3-phase change. So constantly charging to the natural battery dynamics, eliminates your overcharging and undercharging. And your profile is specific to battery temperature. So when we know the temperature of the battery through like your temp sense harness, we can adjust the set point to bring the voltage down as we're going through, or up, depending on what conditions you're seeing. So if it's the middle of winter, you come up, the vehicle has a temp sense harness, you see 15 volts on the system, you're not actually having a problem. It's not over voltaging. It's compensating for the temperature and putting more into the batteries. Same thing as you're out there in the middle of summer, you go to check it, reads 13.5. You know the set points are 14.5 on these vehicles. Well, it's got a temp sense harness. That set point can move on you. So you might not actually be having a problem with the vehicle. It could just be the set point with the temperature sense harness. So you might have to keep an eye on that as those get added into vehicles. Another for our diagnostic LED blink codes. The LED codes aren't standard for all models. Some models are going to have a little bit different, but generally amber is standing flat, standby or no AC, so it's not seeing rotation at that point. You get a solid, generally it's a low voltage or an overloaded condition, where the system's outputting as much as it can, but it can't bring up the voltage, no matter how much current it outputs. Green solid, we're all good. Red solid, high voltage. Possibly tripped an OVCO cutout, so over voltage cutout. If the system saw too high of a voltage, the alternator will shut itself down to attempt to bring the voltage down. Red flashing, there's our OVCO trip. And red and green, downloading data. So in cases where you're changing the program for downloading your data logs or things, if you get into the J1939, you'll see a change in those, but you shouldn't see that in normal operation. Normal operation, if it's popping back and forth like that, you are probably having some issues going on with that vehicle. Now, our alternator output. So this is an output curve of our C510. You'll see that there's two curves here. This first curve is at 72 degrees Fahrenheit. This lower curve is at 200 degrees Fahrenheit. Whenever you see a spec for an alternator, they're spec'd at the 72 degrees temperature. But in your actual engine operating temperatures, you're going to see closer to the 200 range. Usually within 10, 15 minutes of driving, you're down at this lower curve for your output. Generally, your RPM ratios are 3 to 1. So 3 times the alternator RPM is your engine RPM. So the most important things are your output at idle and your output at high temperature. So here we have our C505, 527, 531, 534 models, this style alternator. We have our alternator RPM. We have our two curves, our cold and our hot curve. And then right here, right about 2000 RPM alternator, we call out idle. That's idle in your engines. Because if you think 2000, 2100 alternator RPM, 3 to 1, that's 700 for your diesel engines. So on the unit that is rated at 350, 375, at idle, you're going to get 200 out of that unit when it's going. A little bit less once it gets hot. So even though you read an alternator and you see that it says that it's a 500 amp alternator, it is 500 amps at 6,000 RPM, because that's the point at which they take the rated output on the units. Here we have another unit. This is our C680. Again, we have our curves, our hot and our cold. Again, we have our idle. You can see here we're getting upwards of 250 at idle. And then you also see is that there's a starting point down here. So our alternators have a soft start. To decreased load on the engine drive and on the starter, the alternator won't start working until it sees rotation. So your regulator is always getting power through the alternator. When it sees that AC output, rotation of the magnet, it'll kick on when it sees the right amount. Once you have ignition in and power going through it, it'll start turning on. This is to prevent the alternator turning on the second you turn on the key and creating a load on the vehicle. So there's no torque coming out of the alternator other than just to spin the shaft around. Now here, I have two alternators. Alternator A is 300 amps. Alternator B is 320 amps. Which one would you guys pick for your truck?